This lesson is on L'Hopital's rule, and the lesson goal is to explain the rules and conditions for L'Hopital's rule and use these skills to determine limits of a function. So the rule in simple terms is that when given an indeterminate form of a limit, so it is 0 over 0 or positive negative infinity over infinity, by differentiating the numerator and the denominator, the limit will be found based on the rule called L'Hopital's rule. So the general notation is the limit as x approaches a of f of x over g of x is going to be equal to the limit as x approaches a of the derivative of f of x over the derivative of g of x. So there are two conditions. The first condition is that when f of x and g of x are both equal to 0, then the general notation is true and that the derivative of f of x over g of x will be equal to the limit of f of x over g of x. The second condition is when the limit as x approaches 0 of f of x and g of x will be equal to positive or negative infinity. Then the general notation is also true. So we have the rules and guidelines. Number 1 is that the limit must be an indeterminate form of the limit when the value a is subbed into the function. So as mentioned above, it has to be 0 over 0 or plus minus infinity over infinity. Number 2 is that you can use the L'Hopital rule more than once for the same function by taking higher derivatives of the numerator and the denominator to solve for the limit. Number 3 is two functions, so f of x and g of x, must be in the form f of x over g of x. So the first example, when subbing in infinity, we can tell that f of x, the top function, is going to be equal to infinity, and the bottom function is going to be equal to negative infinity. Therefore, this function meets the criteria of being an indeterminate form when the value of a is subbed in. The limit as x approaches infinity, we can take the derivative of the top function, 8x minus 5, and divide it by the derivative of g of x, the bottom function, which will be negative 6x. When subbing in a, we get still infinity over negative infinity. We can use the L'Hopital rule more than once by taking higher derivatives. So take the derivative of the top function, which is going to be 8 over negative 6, and then once that's simplified, it's going to equal negative 4/3. And then have an appropriate therefore statement. So the limit as x approaches 0 of sine of x over x. It will equal indeterminate form of 0 over 0. Therefore, L'Hopital's rule can be used. The first thing we're going to do is take the derivative of the top function, f of x, which is going to be cosine of x, and then over the derivative of the bottom function, which is going to be equal to 1. So our limit will be 1. So the next example is b equal to 0 over 0, an indeterminate form. Therefore, we can use L'Hopital's rule. Limit of x approaches 0 of the top function will be e of x minus 1 over the derivative will be 2x. Therefore, we need to use L'Hopital's rule again and find the derivative of the top function over the derivative of the bottom function. Limit is going to be 1/2. Then have an appropriate therefore statement. That concludes our lesson.